Thanks, folks. Thanks for coming over today. Welcome to this session about using AWS to maximize digital marketing reach and efficiency. My name is Mayank Thakur. I'm a solutions architect with AWS and focusing on the healthcare and life sciences domain. Typically work out of Chicago and help customers out there. Now, during my tenure with AWS, I had the privilege of working with many pharma companies. And as you know, pharma companies are subject to a lot of regulations. Now, that being said, sometimes those regulations can come in the way of decreasing your trying to increase your time to market and decreasing your pace of innovation. But this is all for a good cause, though. Now, that being said, there are many companies which are actually working with AWS in the pharmaceuticals domain who are actually trying to go back and run applications on the edge of innovation and decreasing time to market for the ID products and services. One such company is Mylan, which is basically a US-based global generic and specialty pharmaceuticals company who actually overcame all these obstacles and provided scalable solutions by leveraging AWS DevOps practices and methods and lower time to market, all while maintaining robust compliance practices around security and release management practices. And they actually here with us today to share their experiences and their story. So let me introduce David Karpinski, who is the director for global digital solutions at Mylan, and Michelle Sapolia, who is the manager for digital solutions, web and mobile. With this, I will hand it over to David.
Thanks, Mayank. Again, my name is Dave Karpinski. I'm the director of global digital solutions and digital IT at Mylan. This first slide is what the lawyers are making me show. It's not very technical, but it's fun to read. So I'll leave that there for a second. In today's presentation, I'm going to tell you a little bit about Mylan. I'm also going to speak to you about why we moved to AWS, or more specifically, why we moved our digital hosting environment into AWS Cloud. I'm going to share with you two war stories that will demonstrate the differences between the physical and the cloud infrastructure. One is nice and the other one is not so nice. I will also disclose aspects about how we complied with quality assurance, regulatory, and security. And to help describe this, I'll walk you through phases of our journey and show you some highlights as well as some lessons learned. After that, Mitch is going to discuss the how of what we did. He's going to get into the technical details about the automation that we put in place and how this automation allowed us to put in release and deployment processes, as well as some cool things that we can do now that all these things are in place. He will cover the details of various AWS services that we employed, including EC2, the configuration and code management, as well as the deployment, various lessons learned, and he's going to give a quick look into the future of some of the things that we'll be working on. So first things first, about Mylan. At Mylan, we are committed to setting new standards in healthcare. We work together around the world to provide 7 billion people access to high-quality medicine. To do this, we innovate to satisfy unmet needs, and clearly AWS is an innovation for us. We make reliability and service excellence a habit. We do what is right, not what is easy, and we impact the future through passionate global leadership. Just to give you an idea of the scope and size of Mylan, we have a global workforce of more than 35,000 people in 65 countries. We have more than 165, we have products in more than 165 countries and territories. Our global market portfolio is over 7,500 products, and 1 out of every 13 prescriptions filled in the United States is a Mylan product. So this question faces a lot of IT departments. It's a very large question, and it means a lot of different things to a lot of different people. We have found that it's best characterized as a journey and not a destination, and we're certainly not done yet. We started this vision, we started this with a vision rooted in two principles: simplicity and scalability. We wanted to be able to simply manage our customer-facing web and mobile applications. We wanted to automate as much as possible due to our small team size and our large application footprint. We also wanted visibility and the activity in our environment in a single pane of glass. As I've just described to you, Mylan is a complex, global, matrixed organization, and we need to align various teams and processes. This is a big task alone, but if you put in merger and acquisition activities, as well as the ever-changing regulatory posture around the world, it becomes even more challenging. Across all of this, AWS has been the enabler with their breadth of services, their global infrastructure, and their support. And this is both directly through AWS as well as their partner network. And the benefits of this apply across various teams within IT, including quality, regulatory, security, operations, DBAs, just to name a few. So to have a story, you have to start at the beginning. When I joined Mylan in 2014, we had around 30 websites and 2 mobile applications. We had a digital team of about 6 people. And we were in a co-located environment that was out of the Midwest of the United States. This is your typical dual everything physical environment where we had dual load balancers and dual routers, for redundancy. We had a SQL Server database cluster, and we also had a 100 meg internet connection. This worked well for us. We had just gone through an upgrade of Sitecore, and Sitecore is our content management system, when we upgraded at that point to version 7.1. And we also upgraded the hardware into larger hardware within the physical data center. And from an application perspective, we embarked on a journey to create a reusable framework where we could churn out CMS-enabled websites with common components, reusable assets, and content. And we also launched a new corporate site early that year, and we rolled in a template where we used it to launch 22 more corporate websites worldwide in multiple languages in late 2014. This doubled the number of applications we were hosting, and we were growing fast, but our infrastructure certainly was not prepared for what happened next. This is the first of 2 events or stories that I'm going to tell you about. I'll refer to this as event 1. For this event, we're still at our physical co-located environment in the Midwest. As Mylan is a publicly traded company, we have quarterly calls where we report financial results to the street, as well as make any announcements of the day for that. My team, whenever we have these quarterly meetings, we go into a war room where we monitor all of the systems, and we also make content updates based on the news of the day. This particular call started, as it normally does, with a slight uptick in traffic, but about 15 minutes into the call, we started getting alerts that our websites were not responsive. So we obviously went into troubleshooting mode, and we began to investigate what was going on. We could still get to the web servers because our VPN was on a separate circuit. And we could see that traffic was trickling through and that the web applications were up and running. And after a little bit of analysis, we could see that a majority of the traffic was going to a couple of different websites. And Mylan.com clearly was one of them. But these sites were still not accessible from the internet. The only thing we could do was wait for the traffic to clear. So as this was going on, I called our provider, and it was a little noisy inside of the room. So I stepped away or pushed myself away from the table and turned around. And as working with the engineer, we discovered what the root cause was, and I turned around to deliver the root cause to my team, and I came face to face with our CIO. Well, I delivered the root cause to the team, to everybody that was there, and the root cause was clearly a sustained level of traffic that our 100 meg internet line could not handle. And the CIO had brought along a few other people from the executive leadership. And our chief security officer said to me, "Do you have any logs in our firewalls and load balancers to see where this traffic was coming from?" And I asked the question of the engineer, and apparently these logs roll off. And we didn't have any logs at this point based on, to see where things were coming from. So clearly this was an uncomfortable situation for me. This was the first time I met the CIO, and he was asking me questions about an incident where I had little detail, hard data, and a firm root cause. This is not a good place, for me, at least for me, to be in. So after some digging, my team figured out there was traffic that did trickle through, and the traffic that did make it through did not appear to be malicious in nature. There was simply just too much of it. At this point, we were in the early planning stages of our move to AWS, and I knew that if I were ever in front of this group again, I did not want to repeat this same experience. So with this experience in mind, along with guidance from our AWS partners, we established a list of requirements based on the design principles of simplicity and scalability that I mentioned earlier. Overall, we were considering scenarios like, if something were to happen, I wanted to be able to see it, describe it, and repeat it if necessary. Where possible, I wanted to automate server management, configuration, and code deployment, and changes needed to be tracked as well as easily rolled back. I wanted to support requirements for our quality, regulatory, and security teams, and the environment has to be highly available and globally scalable. And cost needs to be managed and optimized as we learn. We want to use what we have and efficiently use what we have. We don't want to overbuy, but it's good to have the horsepower if you need it. So, one of the teams that we started working with, we were already working with them, but that we started working with when we were doing our transition to AWS was quality assurance. Working with the quality team certainly has its challenges. For digital, they were mostly concerned about all the processes that were involved in our infrastructure. During our initial risk assessments, our lack of PHI in these digital environments and our strict regulatory and compliance posture for our content that end users would see resulted in a non-GXP validation. As a side note, for anyone that doesn't know, GXP is good practices, and the X in the middle is, you could replace it with laboratory, manufacturing, or in this case, infrastructure practices. All of the resulting documentation that we had was tracked in our Documentum repository. And this would also include at a later time as needed any corrective or preventative actions or CAPAs or any incidents that would happen after that. We also began to enter in configuration items in our configuration management database or CMDB for further tracking. There were lots of discussions around how we manage change in our environment as well. This change management process included decoupling the areas and teams responsible for our AWS environment. For instance, our infrastructure and compute team managed our AMIs, and our security team managed our networks and NACLs and security groups, and the DBA teams would manage our RDS instances. And all of these processes had their own standard operating procedures, or SOPs, for change management. Finally, for the application Sitecore, we were already putting in a standards-based SDLC, including a source control environment, as well as an automated deployment process. But we needed to ensure that this worked within AWS. And we needed to make sure that they were repeatable and logged. In general, the tracking and documentation for the content that a user sees is managed in a separate environment or separate process and a separate team, and it's not in AWS. It consists of digital marketers snagging screenshots of our content before it is pushed live. And they store these screenshots and they work with the Mark team to annotate, review, and approve each of the pieces of content. The primary system used is Viva Vault. The Mark team is the marketing, advertising, and regulatory committee, and it consists of legal and regulatory resources. From an AWS perspective, we had to support Sitecore, our content management system. And our Sitecore has a workflow and, system that exists inside of it, and it's definitely, we had to design a process that would follow the regulatory process and move content through the workflow and gain approvals and obviously audit all of those changes. The auditability of the lifecycle of content is important. And then based on the global nature of our environment, there are many users who are publishing at any given time, so the performance of the content management system is key. Now for Mylan, the security team definitely has its challenges. I think everyone who deals with the security team knows this. They're always there to help, and they're always there to advise us on what we should be doing. One of the main things that they needed was visibility in the environment of what is happening, real time if needed, and the who and the how of the information surrounding it. To minimize, their goal is to minimize the attack surface, or thus minimize the risk. And one thing that we added, which didn't exist in our Colo environment, was an intrusion detection system by Trend Micro. And this was also our virus system as well. In order to keep track of all the logs that are generated by all these systems, we implemented Splunk. And we're constantly looking at trends, application activity, and playing back scenarios when things go wrong. Connectivity is also a large consideration. And I don't mean just connectivity from the internet, but also connectivity within the environments. So we need to make sure that staging environments, we're speaking to staging environments, and production environments, we're only speaking to production environments. This security team was quite active during our initial phase and design of our AWS environment. And they're still involved, they still monitor Splunk, and they're still involved whenever we work on changes to the environment. So this is an overview of our transformation timeline. We could see the outage there at the end, towards the end of the initialization, or the initial phase. As I already said, this outage was a major input into our implementation phase. We launched 60 websites, you can see in 3 different waves there, by September. And then we spent the next 8 months in a stabilization period. The initial phase was full of education. We had to learn who AWS was, what they did, how they worked, see the case studies, see the technology, and experience it. We had several meetings within IT, as well as with our AWS account and tech partners. Digital was picked as the first team to launch into the environment and into AWS. And it was definitely a collaborative effort to put together a solution with input from everywhere. In this next phase, once the design was complete and the initial cloud scripts were delivered, the environment was turned up, the automation scripts was put in place, we had to install the web applications. This consisted of about 60 websites. Now, right now, we're serving about 150 websites, so we've grown quite a bit since then. But there were 4 separate areas to support, and they were all Microsoft .NET-based applications. There were 3 versions of Sitecore, version 6.4, 6.5, and 7.1, as well as a separate .NET environment. And this typically handles some of our static HTML sites, as well as some of our API endpoints. We also had a secure staging environment for each, something that did not exist in our old Colo environment. And a majority of the time was spent setting up the applications, ensuring that they work, testing code, configuration management, as well as the deployment process. And this was entirely automated. We also tested rollbacks, which was another thing that didn't exist in our previous provider. Throughout the implementation process, we engaged a software quality assurance, a testing team, to compare what we had put into AWS with what was out there on the current live web environment. And we strategically chose sites for each of these different waves based on complexity, readiness, traffic, as well as business need. And as we launched sites, the QA team would review what we launched and confirm what we were, and we were making changes and transitioning over to business as usual directly in live over in AWS. The time we spent on the automation processes that led up to this truly paid off, because these go-lives and transitions were truly non-events. We didn't see any outages or any downtime as we moved from the Colo environment to AWS. So now that we had websites in AWS, we had to go through a stabilization phase. And we noticed that there were specific issues that we had, with various bits of AWS that were causing outages. So between September of 2015 and May of 2016, we made various tweaks, updates, changes to the environment as needed. So if you'll take a look at this slide right here, on the left side it shows the AWS-related challenges that we had as more infrastructure. And then on the right side, the application structure associated with it. A lot of the issues that we had were around high number of connections to RDS. And the challenges that we had with our DBA team was to learn how to use the tools in RDS to see RDS, track performance in RDS, as well as troubleshoot RDS. We had to overcome those. We even went through a sizing exercise where we bumped up the size of our RDS instances to M4s. And then based on all of those learnings, we're now able to clone RDS instances for use in new staging environments, testing environments, and various other use cases. One of the challenges that we had back then were SQUID instances. SQUID instances were proxy servers that would allow internet access for our EC2 instances in our VPC. The challenge with them was we had a hard time showing whether or not they were actually up and running. They looked alive, but they weren't routing internet traffic. And the problem with that is our EC2 instances need to download code from S3 and obviously go to the internet to get that. And without internet connectivity, our automation was not working. So we've obviously since then switched to the NAT service that's offered now, but that was definitely a challenge. And within EC2, we actually had a couple of challenges as well. One was the performance of the network, which we disabled the TCP offloading option on our Windows 2008 R2 servers we were using, as well as the EC2 config service logging. We had challenges around that because we needed to make sure that all activity for regulatory and quality reasons, we needed to make sure that all of that activity was logged. On the right side, our application, the Sitecore Analytics database, was running at high connections. And this ended up being an issue that we were able to resolve by working with Sitecore through configuration changes as well as some patches. Another challenge that we had at that time was there was no run command for EC2. So we had to come up with a way to execute commands across our entire fleet, which we wrote a custom solution for that. We also had challenges around bringing EC2 instances into an ELB pool when they weren't ready, and that just required some changes to our bootstrapping as well as the ways that we were testing to make sure a website was ready to serve content. And managing permissions in S3. As I said, our EC2 instances read their code from S3, but they also write to S3. So you have to get your IAM roles associated with your EC2 instances correct so that they're writing to write the correct places as well as reading from the correct places. This leads me to event 2. So now, as noted, by May of 2016, we were pretty stable at AWS. If we were to receive any alerts, at this point, it was a surprise. On a routine afternoon in late August of 2016, we had settled into a normal work patterns after lunch, which was really watching cat videos on YouTube. But we got alerts for latency that was our websites were latent or down. And we began to look into this. And when we went in to look into AWS, we noticed that our internet traffic was up 14 times of what it was just minutes ago. And our RDS was telling us that the connections were up higher, but they weren't at a level where we had seen them based on the problems that I had discussed before. The difference this time to the previous time was that AWS was already scaling in new EC2 instances based on our ASG rules. No intervention. All the automation was working as needed. We could actually see what was happening real time and do something about it. We could send commands to all of our applications to clear caches and reset application pools to make sure that these web applications were up. And the best part is that at that time, we were the only team that was aware that there was a problem or there was any outages. So within 20 minutes, we had doubled our EC2 fleet. We ensured that the application remained healthy while we watched traffic slowly go down over the next several hours. And we manually set our EC2 instances to remain high over the next several days because this traffic repeated itself during every news cycle after that. Oh, and by the way, I didn't get to see the CIO that day. So now I'm going to turn it over to Mitch, who's going to talk a little bit about the tech that went into our journey.
Thanks, Dave. As Dave said, my name is Mitchell Sapolio. I'm a manager under Dave's team in the digital solutions team. I'm also an AWS certified solutions architect and happy to talk to you about any questions you have after the session. Everything that Dave put in front of you, paved the way. I'm going to dive into these components and see how we build our environment. So behind me is a list of AWS services. It's purely an eye chart, to be honest. But as a starting point, these are the services that helped us achieve our goals. Now, the circa 2014 I put up there because this is when we actually started. These were the services that AWS had available to us at the time. There's a vast number of new tools out there today that you could leverage based on your application requirements to achieve the same or similar results. But this is what we had at the time. Such tools as Code Deploy would fit our needs, but we didn't have it. After some analysis of our application, Sitecore, we determined that EC2 was the right fit for the compute stack of our application. And with this in mind, we leveraged these other components to decouple an environment to lower the risk. So let's dive into some of these components and see how we put them back together. So this diagram is a great diagram to show you how big our application ecosystem is and our footprint. It also depicts that our environment is hybrid in the sense that it spans from a physical data center on the left to our AWS cloud environment on the right. And this is common for most people that move into the cloud. You don't forklift everything all at once. And we are still trying to eventually get the rest of our our servers into our AWS cloud. For those that are familiar with how Sitecore is configured, there is a delineation between the content management side of your Sitecore environment and the content delivery side. And we matched our release management processes to match those requirements. Now, similar to any SDLC, it starts with source control. We're using Microsoft Team Foundation Server on the top left as our source control repository for all code, content configuration, and all of our AWS automation assets. Now, this enables us with a smooth change process. We have versioning in Microsoft TFS. Now, if you follow the arrows through our environment, you can see the directional flow of code, content, or configuration through our various environments. Changes to code follow a scripted path via our SDLC through the environments. At each gate or environment, code is tested and approved before it proceeds to the next gate. Now, when code or configuration reaches one of our AWS environments, we have two up there, production and staging. Our custom developed deployment solution, pushes these using common AWS CLI tools, pushes those packages up to AWS S3. The respective servers in our AWS cloud listen to those respective S3 paths and pull down that code and configuration on a rolling basis until it's propagated across the entire fleet. Content, on the other hand, it follows a similar process, but it is slightly different. We have content managers across the globe making changes around the clock. And these are all being done in the Sitecore CMS system. Those changes follow a workflow process through the environment where editors make changes, approvers approve changes. This also includes email notifications to those approvers who are part of that MARC review team so that they can review this content before it goes live. As stated previously, that process is using Viva outside of our AWS cloud environment, outside of Sitecore, and it is still a manual process. Now, given the scale of that environment and all of those people that are involved, the only way we were able to achieve this is via automation. And that brings me into, you see that? This diagram shows the logical components that are required for a dynamically scaling EC2 environment. We wired up these components, and bam, we have servers. So we're done, right? We can put a number in an auto-scaling group and have that many servers. Well, they're not digital. I mean, they don't have websites or APIs on them. You can't browse to mylan.com and have it resolved to that server. So this is where we needed to decide how we were going to be dynamic. The concept of building servers manually just didn't work. It wasn't really right for us. So we started with a base AMI that we would reuse across our fleet that we'll come back to. Then we configured our launch configuration, which pulls in low-level details such as what IAMI you're using, what instance size you need, you need any EBS volumes, IAM role that you're going to use. And then we map that into our auto-scaling group. Now, I'm not spending a whole lot of time on the auto-scaling group. However, I do want to say this tuning of your auto-scaling group to have scaling policies to scale in and out based off things like network or CPU is a very tedious process. It really goes down to the level of what your application needs to do. How long does your application take to build? Things like that. So we did spend a lot of time in tuning of the auto-scaling groups. And now we have EC2 servers, but they're still not web servers. I love this diagram because this is where our tipping point went between baking of a server versus bootstrapping a server. From the left, option one would be to bake your servers into an AMI. Now you have to start with an AMI, but the rest of your details, like your application, your software, things like that, should those be installed in your AMI and then packaged up and reused X amount of times. Now, if you were to say pros and cons, pro one would be that you could potentially faster boot time because everything's included in an AMI, and as soon as the launch configuration gets called, that server's getting built and it's going to get dropped down pretty fast. However, con would be it may take you, depending on what your processes are for changing your AMI, it may be slower to make those changes. Bootstrapping as a second option serves as a great option too. A pro to that would be technically you have a lot more flexibility in the fact that you're at runtime passing in user data scripts to build your servers. You have a lot more dynamic characteristics to it. It's a lot more flexible. However, potentially a slower boot time depending on what your bootstraps are doing because everything that you pass in is being ran at launch time. So that may be a decision point. So what did we pick? Frankly, we picked a hybrid approach between the two. We have a base AMI that we reuse across our fleet that proved valuable for reuse of that base AMI, so we weren't recreating the wheel for every environment. That base AMI has some security patches applied to it, some base level software that servers are going to need. And then we apply Bootstrap scripts on top of that get pulled down at runtime to build the remaining parts of our servers. So as we got to that point where we made that decision, we had to start pseudocoding what were these scripts going to look like? What did our servers need to build? What did our servers require to be built on? So first time you build a server manually, document your steps, start writing pseudocode, and work backwards from there. So once we had a rough idea, we started to get our hands dirty and start playing around. From the icon on the right, for those that aren't familiar, we leverage the PowerShell language for all of our Bootstrap scripts. Our web front ends, or WIFIs as we call them, are Microsoft servers, and the language has good extensibility in what we need. And Dave and I were familiar with the language, but we wanted a little bit of a challenge, so we chose PowerShell. Each environment that we manage has its own set of Bootstrap scripts in their respective S3 bucket. These scripts leverage common functions from an include file that get pulled down at runtime so that we don't copy existing code. Like methods, you don't need to copy. If two scripts are going to use the same method, don't copy them, create your include, and if they're going to share it, that's what we do. So anytime we packaged on that simplicity of when a server gets built, 4 scripts are going to be launched, pulled down and launched at runtime. If we were to look at these scripts, from the top down, initialization does some base level downloading of software and tools that we're going to require. Splunk is one of those tools so that we have real-time visibility into the logs on our servers, are our Bootstrap scripts running properly, what's happening on there, as well as after the servers are in production. Deployment, our deployment PowerShell script handles extracting and configuring of our web applications. This is the code behind for our websites to function. Now, we follow a base and delta method for our web code. So day 0 of a website, that becomes the base. And every resulting build or update to that website or API becomes a delta. Therefore, during this step of our deployment of our server, the order of operations in which those code packages is downloaded and extracted becomes very important. Add to domain, I don't know if anybody knows what that does. That adds the server to the domain. It's very difficult. This is obviously done for AD group policies and security policies that we require. After boot, however, may not be so obvious. So there were some tasks that our web servers needed to run, and we noticed that these tasks needed to be configured after the server was renamed and added to the domain. So we found a location in the registry in which, on a subsequent reboot, our PowerShell script would be launched, and the steps in that script would be executed. Inside that script, we have scheduled tasks and folder permission items that we launch on our servers, such things as IIS weblog cleanup. Anybody that's run a web server out in a production environment for a long time knows that those logs start to get massive, and if your server drive fills up and you don't have something to dynamically build your drive bigger, things stop working. So at this point, with those scripts kind of mapped out, we have the EC2 components in place from our IMI, launch config, and autoscaling group. We now have working web servers. But let's take a moment to get back to one of the foundational reasons that we're all here, which is quality, auditability, logging, and compliance. Oh, went the wrong way. So I know this TV screen is big, but this is a small code snippet that I could fit on here. This gives you a good idea of how extensible PowerShell language is for Microsoft servers. IIS is already installed from your base OS. However, you have to still configure it. Anybody that's done it manually knows it's kind of painful. We're able to actually to configure IIS in one line. It doesn't look like one line here on a screen, but it is essentially one line of code to configure the IIS application. We also added custom logging to our PowerShell scripts. No custom code is good. Custom code is only as good as the logging that you put into it, because it's a human-created script. All these Bootstrap scripts are version controlled in two places. One, in our TFS source control repository, as well as our AWS S3 repository. And that enables, version control. Now, we achieve release management by having multiple environments through which we can test Bootstrap logic updates to lower environments rather than testing in production. And everybody seems to relax a little bit and exhale whenever we say we don't test in production. But let's look a little bit deeper into the logging. We write all of our Bootstrap scripts to transaction files. However, we noticed when we started this that our transaction files had a 0 KB size. We sought out some help from our AWS partners and found out that the EC2 config log, since we were passing these scripts in via the user data section, the EC2 config log was consuming all of that transactional output into the standard out. So we repointed our log aggregator, Splunk, to the EC2 config log, and now we have our Bootstrap logs. This is a very key point because in our environment, or environments, we have several servers, and the process of manually RDPing to a server to look at logs to see if a server scaled in right or if it's 99.9% correct, it's a very costly operation. And with our team size, we can't do it. Really can't do that. And to be, compliant, you need to have that set up as an alert or, be able to see that happen real time. So this is the example that I just went over. You can see that the PowerShell transaction file is actually created. It says it right there. But if we would go look at it, there's nothing in there. These logs also, the timestamps in these logs help us tremendously with tuning of our auto-scaling groups so that we can see when our methods get fired, when they complete, when the server is actually done building, as well as performance enhancements to those methods. Are we doing things the right way? Can we improve on them? So these timestamps, we're able to see IIS takes this long to configure, your folder permissions take this long to configure. So let's not leave out QA. We're talking about logging, and QA does like that, logging, but let's talk a little bit more about QA. So logging in our Bootstrap scripts does help QA. It is a requirement. However, what about changes to your environment outside of just Bootstrap updates? Not just building a server. What about code behind for your websites or content updates? The logs shown here are generated from our custom deployment solution, as well as outputs from the Sitecore workflows in our CMS system. Now recall the application diagram that I showed in a few previous slides. Code deployments follow a scripted path through the environment. Each time the code behind for a website moves through the environment, it's logged. Similarly, content editors or marketers across the globe make content changes. Each action that they make, whether it's an edit or a publish, is logged. That's very important. These logs all roll up and get consumed by Splunk real time so that we have a single pane of glass to see what has transpired. So to highlight this, from the top down, you can see the audibility of our code deployments. Date timestamps are something that's common for everything. That's a must. Followed by a site or build ID, the target, as well as an additional comment, which also supports this solution. Through that, it also supports rollbacks, which is something that we didn't have before. So if we notice that the new code behind for a website isn't functioning in an environment, we can roll that back immediately before anything, we have a major issue. Now this custom deployment solution, I know we're not showing it here, but this is something that we began building prior to our AWS migration. It's not something that came out of the migration as a requirement. It's something that we started before that. And it proved valuable since we span from a physical data center to our AWS cloud environment, and certain solutions have issues there. So our custom solution actually proved very valuable for this. Publishing of content in our CMS system is another concern for QA. Who made a change? What did they change? When did they change it? So through Sitecore, through those workflow groups, certain people have levels of access. Certain people can edit, certain people can improve. Regardless of their levels or rules within our Sitecore CMS system, all these actions that they take are logged. Who published, what they published, when they published it, what was the target. So what about our security friends? I feel like we're leaving them out. As Dave said previously, security tools such as Trend Micro are used in our web environment. Now, these tools get installed as one of the first steps in our initialization script as the server starts getting built. This provides our security team with IDS monitoring prior to the server even servicing traffic to the outside world, and that's very important. I'm not sure if you would say this makes them happy, but it certainly helps. And it helps keep us lower at risk. Just to highlight, we install Trend dynamically regardless of the MSI version. And we log when it was installed, when it phones home for orders. And that's important because we want to prevent our web front-end servers or Wi-Fi's from servicing traffic if it doesn't actually phone home and it's not actually protected. Just like everything else, all these logs get aggregated and consumed real-time across the environment, giving security insight into all these activities. So let's put the last slides together in a bigger scale now. Take into account all of the components that we just put together. Combined with the logical operations of bootstrapping, we ended up with dynamic EC2 web-facing servers. You can go to sleep and servers can scale for you. It's a very refreshing feeling whenever your environment lives and breathes. We took those logical patterns from that first environment that we built, and we expanded on it to create other environments. Our initial rollout, after our primary testing to our AWS cloud environment, we created 3 stages of our environments: staging, preview, and production, of which there are multiple versions of them. And you can see this starts growing out of hand, and you're redoing the steps that you did in the previous. Doing this by hand becomes time-consuming. However, taking the logic that we just went over, all the heavy lifting was done. We basically had to copy those patterns to the next environment. And using CloudFormation, you can even make it faster. So we began to realize more potential with logical patterns like this, for things such as upgrade testing. I want to test software on a production-like environment without having to wait for 2 months for the server to get built. We also can create developer sandboxes. Have you ever worked with multiple third-party vendors? What's the first thing that they say? Send me your code, content, configuration, databases, the mayor, and I'll get back to you in a couple months with my analysis. I mean, who has time to FTP all these things? I think that some of them can be very large. Databases can be very big. So we realized if you took the logic that we used for our first environment and made a few tweaks to make the environment actually bigger, you could create an environment that a developer could use, break, destroy, throw it away, scale in a new one. The man hours needed to build one of those is, well, you could say almost zero, because all the logic there, you still have to have somebody either run the script or click the button. And it also helps lower the risk of code and configuration into our environment, because if they leverage those developer sandboxes, they should have working code by the time they introduce it into our source control repository as a successful build, because they've tested it on a developer sandbox, which is a clone of a production environment. So I just went over a lot of technical points in a very short amount of time. I wanted to take a moment to reflect on some of the items that we had to overcome. Your environment is now alive. Your auto-scaling groups scale for you, and you can sleep. Do not walk away from your auto-scaling groups and think that you'll never have to tune them again. These are, as your application grows, your scaling policies will also need to be changed. If you do the right logging in your Bootstrap scripts, if you use them, your log output of that, you can see that evolution. Is your server build time taking 10 more minutes a month, or 10 more seconds a month, and you realize that your auto-scaling policies need to be adjusted in 3 months? Things like that you need to take into consideration. Real-time log visibility. When you're dealing with a dynamic environment, real-time log visibility is crucial. We're using Splunk. However, there's several other log aggregators, log solutions that you can leverage that will fit these needs. We had several use cases for Splunk, so it fit for us. Tools for quality, regulatory, and security compliance. Such things as IAM for removing hard-coded keys off of servers is very big. CloudWatch, CloudTrail, S3, they all make QA, security, and compliance happy. The SDLC process flow paired with code and configuration provide a controlled release management and quality and the ability to roll back. And the other couple things at the bottom here are lessons that we learned the hard way. One of the first one is don't boil the ocean all at once. It goes without saying, but in AWS, there are so many services out there that you can essentially get lost and try to bite off more than you can chew, so to speak. So start with what you know and build on it. The application requirements, your infrastructure requirements, your quality requirements, and expand from there. You can't help but fail if your application scope for your migration isn't clear from the get-go. Spend ample time on your planning phase and make sure your requirements are clear. That was the last one, excuse me. Work closely with AWS. They're here for you. If you don't have account rep, I'm sure they'll sign you one. And you will succeed 98.75% guaranteed. The last thing I'll bring up is our next steps. So at Mylan, we're continuing to evolve. And AWS is a cloud technology that's ever growing. So that's why it's a journey and not a destination. You don't just go to the cloud and never have to change anything again. And I'm sure in our sessions here, I think last time there was plus 20 or 30. Don't quote me on that. However many new tools came out. New things are going to come out. We are also going to have to think about our solutions that we have here. Maybe there's a new tool that can replace all of this. So some of the new things that we're looking at. One major concept in the digital space these days is content as a service, especially when you start servicing data up to multiple channels, such as mobile apps, websites, Amazon.com, and other third parties. With this in mind, there are a vast number of AWS services that you can use to decouple your environment, such things as API Gateway. So we're going to leverage API Gateway combined with decoupled Lambda functions behind it that will allow us to support a global footprint without relying on physical EC2 servers. So you can point that's very key is your environment can be built to be efficient, but serverless is arguably a little bit more efficient. So Behind that, we'll also be using CloudFormation scripts for this environment, as well as CloudFormation to clone environments. Now, we already went through a pilot program in Frankfurt to build a sister VPC to support upcoming GDRP, and we'll be expanding on that for other VPCs in other regions. We're also going to look at, looking at using a RDS version of MySQL to support M&A activities of Linux and PHP websites. We intend to lift and shift those over into our AWS cloud, not only for the cost benefits, but also for the scale and the efficiency in the environment. Amazon Workspaces is a very, very cool use case for us. So as we went over before with the developer sandboxes, AWS Workspaces we see as a good fit for mating with those developer sandboxes. So the developer sandbox can have your server environment, but what about the tools that your developer needs, your IDEs and other tools that a developer would have on your laptop? Is the EC2 server the right fit for that? This is where we see a possible fit for workspaces to come in, since we can plop this into our existing AWS account in that VPC where all of the data already exists next to that developer sandbox server. So at this point, Dave and I would like to thank you, and if you have any questions, we can answer your questions.